Hello, my name is Tony Abate. I'm the Chief Technology Officer for Atmos Air. And also I am a voting member of SSPC 241, which is an ASHRAE committee that wrote the 241 standard we're going to talk about today. So I'd like to bring my presentation on the screen and share this with you. I entitled this presentation, Understanding the New ASHRAE Standard 241 and its Impact on the Built Environment. And I think as we go through this, we'll see that it does have a great deal of importance to buildings and indoor spaces of many types and keeping them healthy and safe. This is just a little snapshot of some of my ASHRAE activity. And again, these committees are all involved with either designing standards for building systems or test methods for different products and processes. Also, I just created a new group that's looking at indoor air quality monitoring devices, which I'm pretty excited about. And the US EPA has produced lots of different statistics talking about the importance of indoor air quality. And really relates to the fact that we spend a lot of time indoors, and indoor air can concentrate and get much worse than outdoor air, and basically cause a lot of illness and a lot of degradation to health. Also, there's a great deal of awareness of indoor air quality. Many groups are talking about the fact that they're concerned about the air quality in their buildings and want to know what building owners and operators are doing about it. Certainly, the pandemic created a lot of awareness of the danger of poor indoor air quality. In the U.S., the EPA announced a Clean Air in Buildings Challenge, which has really helped to really promote improving indoor air quality and protecting public health. This was done back in March of 2022. That led to a summit at the United States White House to again look at how we can improve the air quality in our buildings. This, of course, a lot of it was spurred by the experiences learned during the COVID-19 pandemic. From that point, the White House came to ASHRAE, and in November 2022 asked ASHRAE to develop a national pathogen control standard. ASHRAE put together a committee. I was invited to serve on that committee by the chair of the committee, Bill Banfleck. We started in February of 23, and by late June of 23, at the ASHRAE annual meeting, we approved the standard for publication. As far as ASHRAE is concerned, this is a very rapid development. Usually standards in ASHRAE may take years sometimes, but we knew the importance of what we were doing. One thing that's important to understand is that this standard is not meant to replace other standards. It's really meant to enhance them. There are different ASHRAE standards that deal with ventilation and acceptable air quality in indoor spaces and healthcare facilities and also residential applications. And this standard is meant to build upon those. ASHRAE has done a lot of outreach as far as Standard 241 is concerned and about the importance of it, calling a groundbreaking standard. And as we get into it, you'll see why this standard is a very different approach to looking at the health and air quality in buildings than maybe some ASHRAE standards had been previously. Again, what is the purpose? It's really to establish a minimum requirement to control infectious aerosols and reduce the risk of disease transmission. And really that's in all types of occupiable spaces. It could be new, it could be existing, it could be a major renovation. Now, the requirements of the standard cover a broad range: design, installation, commissioning, operation, and maintenance. Again, very different than some ASHRAE standards that really are more focused on design. Also, important to understand that Standard 241 is really looking at control of long-range transmission of infectious aerosols. Really hard to do much to short-range transmission, which is usually direct contact. So again, this is long-range transmission protection. One important development from this standard is what's called infection risk management mode. And again, this would be a different mode of operation that the building would go into to really reduce the infectious aerosol exposure risk. Now, while the standard doesn't give exact criteria for when to use IRMM, it does fall in the hands of those that might be decision makers, like a public health authority, like the owner operator of a building, or even the building occupant. Why not go operate in this enhanced mode all the time? And we're going to talk a little bit more about that. But one of the main reasons is that the risk varies. So again, sometimes there is a very increased risk of a spread of an infectious aerosol. Sometimes there's little risk. So again, IRMM does not need to be in place all the time, but rather when the risk is considered immediate. One very important development from this standard is something called equivalent clean air flow. And again, as you can see the definition here on the screen, this means the flow rate of pathogen-free air that, if distributed uniformly within the breathing zone, would have the same effect on infectious aerosol concentration as the sum of actual outdoor airflow, filtered airflow, and inactivation of infectious aerosols. Why this is important is that we understood that outside air, while very good at diluting concentrations of indoor contaminants, wasn't the only way to deal with these contaminants. Air cleaning was very important when it came to compliance to this standard. So rather than look at things in terms of cubic feet per minute of outdoor air, as most ASHRAE standards do, everything here is looked at cubic feet per minute of equivalent clean air. And that really brings it to sharp focus, air cleaning, because in addition to outdoor air, well, obviously air cleaning can reduce the amount of pathogens that might be found in a space. So that's why equivalent clean air was developed. We found this was going to be very important because as we looked at what was needed in a space, just using outdoor air would make it very difficult for a building to comply. As we look at these tables, we can see that the equivalent clean airflow rates are substantially higher than looking at just standard outdoor airflow rates that might be found in the ASHRAE 62.1 standard. So again, it really emphasizes the importance of air cleaning, or really looking at your ventilation system very organically, looking at outdoor air plus filtration plus air cleaning. You can use all those methods to build that equivalent clean airflow rate. And again, it can include a myriad of things, mechanical and natural ventilation, air cleaning from multi-zone ducted air cleaning systems, air cleaning systems that serve individual spaces. So think of a self-contained air cleaning system. And then those that either capture and or remove or inactivate airborne pathogens. That could be filtration, that could be germicidal ultraviolet light, and that could be bipolar ionization. The standard was not meant to really identify or require different technologies, but to really be technology agnostic, just looking at how you could meet the equivalent clean airflow rate for the type of space you are designing to. A very important aspect of this standard is what's called normative Appendix A. And normative Appendix A really details out two important aspects of air cleaners, and that is requirements for effectiveness and requirements for safety. We looked at different effectiveness measures, what we call consensus safety, consensus standards. Those could be things like ASHRAE 52.2, the ISO 16890, ANC AHAM AC1, AC5, etc. If you have an air cleaning technology that you'd like to use for your ECA, and they have testing to one of these standards, you can now apply that effectiveness to the ECA. Equally as important, though, was that the air cleaner needed to be safe. So we looked at some consensus standards like UL 2998, ASTM D8407, and ISO 14644. And so, in addition to the effectiveness, you also need to have safety testing to one of these consensus standards to be able to use that air cleaner into your equivalent clean airflow calculations. One thing we also understood, as far as the myriad of air cleaners that are in our industry, is that there aren't a standard test for every type of air cleaner that you could use. So therefore, we pointed out in Appendix A all of the different laboratory requirements that should be used if using a customized test that, again, would allow you to use your product or whatever product you are designing for the equivalent clean airflow calculation. One important thing, and you see I have it highlighted here, is that a laboratory that complies with the requirements of ISO IEC 17025 will generally be able to meet all of the criteria that is pointed out in these laboratory requirements. So that's something to really look for, is that the laboratory meets that requirement, and then generally they will be able to meet all of the other requirements, which means that a data from a test that for an air cleaning technology that might not be one of the consensus standards, but might be very valid testing, can be used, and the air cleaner can then use its efficiency into the equivalent clean air calculation. Those calculations would go into this tool that we built. It's a spreadsheet-based tool that helps the designer build their system, their ventilation system, to be in compliance with standard 241. So again, by putting in all of the different outputs into these parameters of things like space volume, ceiling height, supply air, et cetera, you can now come up with your answer as to whether you are in compliance with the standard. This is a continuous maintenance standard, so we meet regularly, and we're looking at many different things to really update the standard. We know that defining when to use IRMM was a little bit undefined in the original first version of the standard, so that's something we're looking at updating. We also see and understand IAQ monitoring has become very prominent in today's built environment, and so we're looking at how to use IAQ monitors within this standard. Adding more space types, energy use. We know in our marketplace that energy and decarbonization is a vital part of any built environment. And so how do we make our spaces healthy enough to pass requirement for standard 241, but at the same time be energy efficient? So many different things that we're working on. One thing to know is that in the USGBC, in their latest version of LEED, they are recognizing standard 241 and awarding credits if you have a space that does comply with standard 241. One thing that's come up very recently here in the U.S. in Berkeley, California, there's legislation pending that would require design to standard 241 to, again, provide a healthy and safe building for occupants of all types. One thing that I thought it would be important to point out is that if you were trying to design your building for 241 compliance strictly by using outside air, there would be a lot of challenges involved. One thing is that you're using outside, or in order to meet the outside air requirements, or I should say the ECA requirements, you might need to increase HVAC tonnage, ducting, many different things that could add a great deal of cost and be quite evasive to the building. And again, you'd be doing this for something that's not continuous. IRMM is only activated at certain times, not all the time. In many buildings that are existing older buildings, it might not be possible to get to any of the ECA targets solely using outside air. And in some places, like a public assembly space, for example, you might need to increase your HVAC capacity 6 times what it would be if it were just complying with, let's say, the ASHRAE 62 standard. So again, lots of different costs involved for the HVAC system, for something, again, that you're not going to use continually. So air cleaning, I think, is a very important answer to this, because with air cleaning, you can avoid a lot of HVAC interruption and a lot of cost and adding a lot of tonnage. But also, if you have air cleaning and your now overall system, which will have, of course, outside air, which will have mechanical filtration, and which will also have air cleaning, meeting the ECA target would now be able to be in IRMM mode all the time. Since most air cleaning systems aren't designed for occasional use, they're designed for continual use. So this also relieves a burden from the building operator not to have to wonder when IRMM should or shouldn't be used. With the right air cleaning technology, you can use it all the time. And again, the standard is agnostic to technologies. One technology I'm very familiar with, bipolar ionization, is very beneficial within this standard, because it's a technology that can inactivate pathogens, but doesn't really require HVAC or mechanical redesign, and is a very low energy use technology. So it's a very good way to help build towards your required ECA. Major engineering firms are already starting to design towards this standard. You probably are familiar with Tetra Tech. They've already committed to using ASHRAE 241. And again, to end this presentation, at our annual meeting in June of 23, member from the United States White House, Dr. Ashish Jha, who was very instrumental in the White House COVID-19 response, came to the meeting. And you see in the quote down here on the bottom, it is one of the most important public health interventions I have seen in years, if not decades. So again, it was very well understood by the White House, who really came to ASHRAE to develop this standard, the importance of this standard to improving the health and safety in our buildings, and again, protecting occupants from the spread of airborne transmission of illness. So I think a very important and beneficial standard. I'm going to end my slide presentation with that. But again, I thank you very much for listening to this talk. I hope you learned something. And again, look forward to any of you who would like to apply this standard, which I think would be very beneficial in your design of indoor spaces. Thank you again.